on golf courses and provide a better. So in that, I was reading about some buffers that are used around school zones. There's a law in California that prevents any agricultural pesticide use a quarter of a mile from school. So they put a quarter-mile buffer around school zones and try to prevent any drift into that from agricultural pesticide use. However, there is also other research that says pesticides can drift as far as 0.375 miles from the site of application. So that's further than what the buffer is. And further evidence that pesticides can transport into homes and they can easily translocate, like I said, via vapors in the air or on residues on our clothes or on our skin. So a lot of the research that I found was focused more on the agricultural side of things, but it's easily transferable to golf because golf courses tend to use the same pesticides, same chemical compounds, and they have a more intensive use than agriculture. There's literature out there that suggests that golf courses actually use 4 to 7 times more intensive pesticide regimes than agriculture per unit area. So it's pretty stark and pretty shocking when you think about all the things that people are concerned about with just agricultural pesticide exposure. If that's 4 to 7 times more in golf, that's a really big exposure risk and potentially a silent one, kind of one that we're not really talking about as much. So with that, what I decided to do with GIS was digitize 71 golf courses around the Denver metro area. There are more than 71, but that's what I had time for in the time. So I'm working on expanding the project a little bit more. But I started with 71 golf courses, and I decided to use what I found in the literature to create buffers, a small buffer of 0.25 miles from the site of application, and a larger buffer, 0.375 miles from the site of application, to kind of, to address where pesticides potentially can drift to. So I wanted to use those to create exposure zones, and I overlaid population census data from 2020 onto those to estimate how many people were living within those zones. So within the smaller zone, a quarter of a mile from the site of application, around 350,000 people, and within the larger zone, almost 500,000 people. So it just brought to my attention this concern, potentially people being exposed to long-term low-dose pesticide exposure from golf course pesticide applications. Even those who don't choose to live next to a golf course. I mean, people often choose to live right on the fairway and typically pay more for those houses. But it also extends out past those golf course communities to residential areas where people aren't necessarily wanting access to the golf course and aren't aware that they are getting some level of pesticide exposure. So, project, I'm currently working on expanding it with a survey. So looking at golfers and community residents' awareness of pesticide use and their perceptions of it. It's still open, and I need more participants. So, soft plug for my research. If anyone wants to take a survey, talk to me afterwards, and I can send you the info. Thank you very much. Any questions? Yeah.
Aerial dispersion or micro flow?
Aerial dispersion, yeah. I did not include any dynamics of like hydrology, but that is an area that I can expand on. Yeah. Yes.
So you're surveying to observe cancer statistics, or just statistics on whether or not people live there? What statistics are you generating?
I'm just seeing if people are aware of pesticide use generally on golf courses, and if they're aware that it is a potential risk living close to a golf course that they could have some level of exposure. I'm not looking at cancer right now. I think later on that could be correlated pretty easily, like with a different research. But right now it's just a very simple survey to get perception and awareness. Yes.
I want to look at Windsor.
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 We have golf courses
Okay. So that's perfect. Yeah. I'll include that. Windsor. Thank you. Yes.
How did you know the correct distance for your buffer analysis? Have you thought about potential kernel density providing kernel distances to go up the specific one buffer distance?
Sorry. Kernel density?
Kernel density.
Kernel density.
Just to go analysis.
I did not look at that. But that is very interesting and definitely applicable. So I would love to talk to you more after this about that. Yeah.
One more question.
Yeah.
Quantify any of the cancer types. Pesticide might be one because couldn't skin cancer because they're outside playing ball.
Yes. Totally. Pesticides are not the only contributor to cancer. I think there's a million things in our environment nowadays that contribute to anyone's illness. So I didn't look specifically at cancer rates. This was more of a theoretical model just to see what the potential exposure is for people. Yes.
I think my one thought is it's really easy to web scrape mortuary pages, which I know sounds kind of dark, but you can web scrape them, figure out where people died and where they lived before dying. It could be a really viable option for you to integrate spatial data, especially in terms of death certificates. SQL would help, but I don't know how in-depth you are into Python or anything like that. But I think web scraping could be a good opportunity.
Okay.
Yeah,
Absolutely.
just creating a geospatial orientation for those deaths and where they occurred and that kind of stuff. I think I personally think that a big motivation that I'm hearing is just proving causation between pesticides used on golf courses, because golf courses are everywhere. Even small communities have golf courses, and I didn't know this was an issue until you brought it up. So yeah, it's kind of scary.
A little bit. Yeah. Yes. Okay.
Like obviously this is your project, there's like everything.
Yeah. Definitely. Yeah. These are great suggestions. Thank you so much. Yes. It's a whole slew. Really, there's been studies that have listed everything from. Well, okay. Let me start with pesticides are typically, but their function is typically as an endocrine disruptor. Basically, they attack the pest, insect, plant, what have it, and disable its ability at cellular level to regulate its hormone and growth. So like acetylcholinesterase is something that would attack. Often they're neuroinsecticides, things that attack the CNS, like the central nervous system of the pest. So cancers associated with that are very high. Non-Hodgkin's lymphoma is also one that's very high. There was a lawsuit in 2018 that actually was pretty landmark. It was versus Monsanto, so Johnson versus Monsanto. He had a major exposure to Roundup, which active ingredient in glyphosate. It's become a pretty common topic now, but the issues with glyphosate. And so he had a big exposure, and basically the court ended up saying yes, despite the fact that there are a million things that cause cancer in our daily lives, this exposure to glyphosate caused your non-Hodgkin's lymphoma. So that one has been a cancerous type that people have really attached to in terms of like lawsuits and class action cases and stuff like that. But yeah, mainly internal organs, endocrine disruption, like reproductive issues, and central nervous system. So it really is across the board, a lot of cancers. It definitely is something that I've thought about expanding into, but kind of in a different way. I'm hoping to study the bioaccumulation of pesticides, kind of how they remain in our environment, in the soils and the plants and the water, things like that. I haven't looked specifically at that issue, but that is something that kind of came to mind when I was looking at where the exposure zones were. There were plenty of communities that were of a lower income than the typical golf course communities still within that buffer zone. And so they were probably receiving some level of pesticide exposure. So I think that's a really interesting area that can also be tapped into. Yeah.
I know one other endocrine disruptor, and it's PFAS.
Yeah.
Have you considered integrating that into the study at some capacity? Because I think that is public knowledge, more or less, especially people who are involved in the lawsuit of being like, hey, there's PFAS in my water, you know?
Mm-hmm.
There's public information on that, especially it being another endocrine disruptor. I'm sure you're familiar being an environmental biologist.
Yeah, absolutely. PFAS and microplastics are ever present in our environment. And there's actually a recent study that came out in November of 2024 that said basically microplastics in the soil give something for pesticides to attach to. And so the residues become more concentrated and more difficult for like soil microbes to digest and degrade them. So there's probabilities of like re-release of pesticides into the environment from like attachment to microplastics. So definitely the combination of compounds and sort of that joint toxicity factor, PFAS, a lot of other chemicals. Yeah, that's something that I will want to look into.
You've got a lot of work ahead of you.
I didn't think that this was going to be something more than like a small niche, small little project, but I actually was just accepted into a PhD program at the University of Wisconsin-Madison, so I'm going to be continuing all my research efforts there.
Great. Sweet.
Yeah, thank you. Yes.
Are there pesticide alternatives that you recommend in your research, or are you fully focused on establishing conservation?
For this GIS project, I didn't, but in my undergraduate thesis, I did recommend like more natural, more organic, more sustainable management options for golf courses. Things that are more like cultural practices, like not growing the grass, they're not cutting the grasses short, or hand weeding, or what they call whipping the fairways. Instead of using a powder or a drying agent, just using a machine to dry the fairways and prevent mold. Yes.
On that point, there's a new company in Kansas called Greenfield Robotics.
Okay.
And their whole goal is to create robots to manage agriculture, golf courses, and minimize the use of herbicide, pesticide, and managing our environment.
That sounds like a future collaborator. Thank you. Yeah, that sounds really great.
Seeking funding right now.
Okay. I hope they can get it. Yes.
Possible correlation.
There's one study from 1996 by Cross et al. They looked at white male superintendents over 55 and looked at their death certificates and tried to correlate that with their occupation. There have been a few other studies that have correlated like occupational hazards to illness. But yeah, I think that's something that can kind of be updated and redone, especially to include women. So that's also another study that I'd like to carry out eventually.
Well, children, because children's leukemia, which is caused by pesticide.
Yes, absolutely, children as well. Yeah. Thank you very much. These were wonderful suggestions, and I will write them all down.
Of disturbance to the stability of plant communities in a semi-arid ecosystem. And so a little bit about me. I originally got my associate's degree at Pikes Peak Community College in environmental science. And then I transferred to Western to finish my undergraduate degree. And I got my degree in biology with an emphasis in ecology and environmental studies. And then I got my minor in GIS. And come my junior year, I really needed some experience. And so I started out as a research technician for this project that I've now taken over. And so I just learned as much as I could. I participated in doing some let counts, which are just like mating rituals that Gunnison Sage-Grouse do, as well as other grouse. And I'm a member of all these organizations, the GPN, the Wildlife Society, and the Colorado Native Plant Society. And so these are just a select few of maps that I've done prior to this thesis work as a research technician for this project. I was fortunate enough to gain some data to mess around with to finish off my minor. And so it's just kind of a mess of maps. But on the top left, I wanted to see if I was able to interpolate data. So a lot of where we collect data is just in sagebrush communities, and we lack a decent amount of data in riparian and bare areas. And so I wanted to see if I was able to interpolate the data that we have and see if that covers into areas that we weren't able to measure. I did have one data set that we did measure because we noticed the heights were really short. And I just kind of wanted to see what that would look like. And then on this right side, I did a supervised classification of percent cover. And so again, I was able to buffer each of my sites where I collect samples based off of the primary cover type. So it was either bare, primarily for grass or shrub. And then I supervised classification on that vegetation. And I wanted to see how well that would match up to the area that I was looking at as a way to see if just to get a better idea of the mosaic on the landscape. I feel like it's really hard to understand, and we only see a select few sites. And then on the bottom two corners on the far side, that's topographic position index. I ran for the previous master student because he really wanted it. And then topographic wetness index. These are just ways to better understand slope and where our transects are, as well as understanding where water would potentially be and contribute to productivity of this vegetation. And then in the center is my final project before I finish my undergrad, where I really delved deep into code. I started out learning Python just a little bit, and then my master's advisor is an R wizard, and so she suggested that I should do things in R, and so I dove into that. And luckily, there's tons of resources and forums that provide great information. So that was just a great start for me. And so I found a way to use HLS imagery, and I removed it like within code. I remotely extracted those images, and I ran NVR, normalized burn ratio. Yeah. On those images, just to see if I was capable of doing that and to potentially reuse that code as a template in the future. And so these are just some examples from my undergrad as means to try to figure out some sort of model that we could use to understand our sites. And so that's sort of like a map. I'll have a better one. So a little bit of background on this project. So Gunnison Sage-Grouse wasn't differentiated from the greater until the early 2000s. The BLM had already had monitoring efforts in place, But then following them being listed and differentiated from the greater, the U.S. Forest Service did not have anything in place to protect them in the case that the population continued to decline. And so there were FCCA agreements that had already been created at that point, but then it was suggested to the U.S. Forest Service to continue to use that as a means to monitor. And so the previous master student for the last 3 years monitored these select sites to see if grazing had any impact on habitat conditions. And yeah, so it's just a way of trying to figure out how can we do long-term monitoring to ensure that grazing isn't impacting this habitat. And so this is a map right here that I helped make for the previous master student, which just shows all of our transect locations across the Gunnison Basin. There's a lot of ground to cover, which is why I try to make models and things. Yeah. And that's his thesis that he finally published. And so this is kind of how our sampling looks. So we have 25-meter transects located in each pasture. And one transect isn't going to be able to summarize, not even at a pasture scale, let alone an allotment scale, and so on. So we're trying to find ways that we can add more sampling sites throughout these pastures to get a better representation. But this is sort of what it looks like. We would collect cover and height data across that transect. There was a Robel pole that we used. That's something that I won't continue to use, but it's what's on that center image. It's essentially a PVC pipe, and attached to that PVC pipe, and they're like alternating colors to represent an inch. And then attached to it is a smaller PVC pipe. It's supposed to be the height of a coyote, and it's supposed to just better show us what cover really looks like structurally, because when we're doing height, that really doesn't say much if that's even functional. But using the Robel, it's allowing us to see if that actually provides cover. But we ended up not using it. There's been some research, which I believe when I was using that, doing the code for that HLS, I put the article that I referenced, but they were using Robel as ground truthing their data as a means to like make sure that their model was accurate, but that's been kind of controversial. So we decided to completely get rid of the Robel. But yeah, we have the LPI that we did, and then in between the LPI and the Robel, I would use scab count as a way to see the intensity, either of domestic or wild ungulates, to see how long they're in those areas. Not the best way of doing it, but it's the best way that we, like the best option that we have. And then I'd also do species richness, so I was getting community plant data as well, because LPI doesn't capture everything. So from the previous master student, these are his previous results. So on the far left, or top left, I guess, it's just illustrating that with less precipitation, we're going to have more sites that demonstrate no cover, and then with more precipitation, specifically winter precip, we're going to have less no cover show up on our sampling site. And then just below that is when looking at, I believe it's that number of cattle to tallest height. So it's just saying with more cows, we're going to have tallest grass height. That was just something to illustrate that when we do LPI, we collect the tallest point of the plant and the bulk portion of the plant. And so AIM data, that's typically done by the BLM, collects the tallest portion of the plant, which is just skewing some of the results, because that tallest portion, the flowering portion of that plant, isn't necessarily functional as far as cover goes versus the bulk portion. And that was just something that he did to just illustrate that probably isn't the most accurate. You're not going to have more cows and taller grass. In some instances you can in more productive areas. Some pastures have shown that with a little bit of disturbance it can promote growth in plants, which I'll get into later. And then on the top right is another graph or a box and whisker that's just showing that we do our monitoring at each transect before grazing, after grazing, and end of growing season, which is from like September 15th until the rest of the cows are out. So it's a pretty long season. And essentially that's just looking at mean forb cover. That was just illustrating how most forbs are really dependent on phenology. It's when they flower, when they senesce and dehit. So So yeah, it's a lot of that sort of vegetation work is really dependent on their own life cycle. And then at the bottom, that one's looking at more summer monsoonal rains, where it's looking at how heights are negatively impacted by summer monsoonal rains, potentially because it causes them to droop a little bit more. But it doesn't necessarily have a positive impact in comparison to winter precip, which is really important, guys, when we get tons of snow and then it's really dry during the summer. It's some fun field photos about this. And we looked at a lot of scat, all sorts of scats. The Gunnison Sage-Grouse have what I call Cheetos, which don't look like that, but that's dusky grouse. They typically forage on pine needles, but Gunnison Sage-Grouse typically forage on sagebrush during the winters. And so the Cheetos look white on the outside, but on the inside they're like this really cool sagebrush color. But during the summer, when they're primarily foraging on other forbs, it tends to be tar is what we call it. They're just like brown piles that you can kind of see, which is fun. You can see the presence of them in those areas. You see them really, they're heavily using areas that they lecken as well. They don't move too far away from where they mate. Yeah, me in the field with Red Mountain in the back, we tend to have a lot more transects there because that's where we have the best population. And so just a little field season summary. So I started this last field season before I even started the master's program. The project is set up in a way where the master's student does 3 summers. So I started my first summer and then I'll have 2 more collecting data. And so, yeah, we monitored for nearly half of the year from the end of May or mid-May until November, the first snowfall. It was like snowing as I was doing transects. A couple of times we go throughout the Gunnison Basin. I don't know how familiar you guys are from that area, but we go all the way down to near Sawash County, all the way pretty close to Crested Butte. So we cover a lot of ground. I completed about 97 transects, given technically we only have like 35 sites, but we visit them 3 times. And by the time I'm done, I'm going to have like 300 plus sites that I'll be monitoring. And then, so rough conclusion, I'm working on a lot of the stats right now as we finish up a report. But most of the sites met stubble heights, which just means they were more than 4 inches, which is just a requirement that the CCA has. That's ensuring that by the end of the season, there's 4 inches left. For the spring, when spring comes around, they have their leks, they nest, and there's at least enough cover for them to have a little bit left until things start to grow a little bit more. Yeah, the Robel continue to capture shrubs. Shrubs are like the main cover that we have is sagebrush. That's the main thing that's providing structure in this area, with occasional bunch grasses as well. We did my favorite part, species richness counts. So I got to be able to identify every plant that I found, which was really fun for me. And there was a lot of diversity in these areas, especially near like Cochito Canyon, which was my first time going there. And there's so much diversity, so many different kinds of penstemons. So I typically only see like one kind of penstemon, Rocky Mountain penstemon, in most of my transects, or like matte penstemon, but I saw like several more, which is really exciting for me. And then scat count was just a really good proxy for us to understand how frequent the intensity level of cattle being in certain areas. I know it's not super accurate because they might just be passing through areas, but it's just something that we can sort of go off of because we do have paperwork that we get from ranchers or permittees that tell us they were in these pastures for X amount of time, but sometimes there's a little bit of bias and that they're not totally accurate, and so this is just an alternative. More photos. The center one is a sagebrush moth. It was my first time seeing those. Those are really cool to see. They just emerged in fall, and we tend to see them a lot early on in the season. They're like these little fuzzy little caterpillars that make like silk tents. They're kind of intimidating because they have like these bristles, but and so just a few of my thesis questions. How does grazing intensity on plant species richness vary with patch productivity? How does grazing disturbance shift patch dynamics? And how do the properties of an ecotone influence the resiliency of an ecosystem? And so some key concepts that I'll be kind of covering. And so along with LPI that we'll be doing, collecting ground data for cover and height. We also plan to do ecological site descriptions, which is essentially keying out a specific area to species level based off of the type of soil that's there, the geological features and formations that were in the area, as well as the above ground plant communities. And that would give us an idea of how that area identifies and how that is on a state on transition mile from retrogression and succession from its historical state. And so with that, we'll be doing like soil stuff, precip, which we'll continue to do, and then potentially above and below ground biomass. So seeing how plants allocate resources between root to shoots. There's been some studies that say grazing on the shoot portion of the plant, or at least overgrazing, encourages a lot of root development as a way of allocating more resources and being able to stabilize themselves. And so some concepts that I'll be looking at is intermittent disturbance hypothesis. So sort of going back to what I was saying earlier, where sometimes grazing can have a positive effect on plant communities where it's encouraging growth, but that tends to be in a lot more productive, wetter areas. When it comes to more arid regions, this hypothesis aligns more with the second model that I have here, where grazing at a certain threshold can be really beneficial, but it's such a really small window that otherwise, if you're not meeting that window, it's going to be really negative. And then patch dynamics, productivity gradients, so being able to look at different areas within those pastures rather than just sagebrush, because for Gunnison Sage-Grouse, they use more than just sagebrush. For cover, they use wet meadows and riparian areas for foraging, especially brood rearing, as well as bare areas for their leks. They have really good acoustic values and they're able to be spotted by their potential mate. And then functional traits rather than nativeness. We have plenty of plants that aren't necessarily native, and that's not so great. A lot of them were introduced for value for cattle, but at some point they do provide some sort of cover and are somewhat functional in this ecosystem. So back to the GIS. A lot of it is data collecting, but my ultimate goal is to potentially come up with some model that can really help adaptive management. And so these are just a few tools that I'm working on right now. I use R to do a lot of my mapping now, at least. And so right now I'm trying to figure out to remotely download all of this data, clip it to my area of interest, and then see if these areas are informed, or at least these models are informative, and being able to help me determine where we should potentially put transects and what would actually work for habitat as well as potential use from cattle. And so on the top left, I have, it's a conservation efforts map that they just made. I think like sometime last year, it was like in the works, but now it's out, which is pretty cool. It's specific to Gunnison Sage-Grouse, so it's looking at primarily sagebrush cover, and it's spacing off sagebrush cover and then any overlap with recreation, roads, and categorizing those by types of threats. And so I'm working on trying to extract that map, clipping it, and then potentially using that to help me find sample sites for next season. The bottom left one is the Rangeland Analysis Platform. And so they have a really good site. They use satellite imagery paired with a bunch of AIM data. So similar to what I do, where we collect a bunch of heights and cover, they put it into this model and they come up with biomass, cover, and productivity models, which will be really helpful for me to figure out which areas are really productive and have a lot more biomass, because those tend to be areas where ungulates drift towards and use for forage, and there might be overlap with habitat, which would be nice to know. And then Prism and Web Soil Survey are just going to be good resources that I'll be using to get climate as well as soil data for my models. The second one is a burrowing beetle. They can sense flesh for like a few miles away. I thought that was pretty cool. And then, and then just some brief acknowledgments. I wouldn't be able to know what I do. Like, I wouldn't be able to do what I can with GIS without my professor, Dr. Phil Crossley. He encouraged me to continue to push myself and do hard things. which is really cool. And yeah, he's just such a genuine person. I learned so much from him, as well as the previous master student, who really taught me everything I know about this project and really paved the way for me. The Forest Service, to be able to fund my projects, my education, which is really cool. And then all of my techs. My dog comes out with me to support me, but I have a bunch of techs that come out with me and just collect data for me, really patient with me as I stare at a grass for way too long. But yeah, any questions?
Have any of the site locations that you guys were sampling in been affected by wildfire at any point or previously? Just curious because this type of habitat, takes 15 to 20 years to fully recover after a wildfire. So I'm wondering if you had taken samples in areas that had been, and if, how your, the vegetables that you're capturing, if they differ in those areas because of that.
Yeah. So we do have a few sites that were prescribed burn for rangeland improvements. And so those areas were rested. And so I was able to monitor those this year. I haven't quite figured out if there's much of a difference. I mean, I know from prior to them burning that area, they were mainly looking to get rid of certain plant species that weren't valuable for grazing. And I mean, they're still there, which is unfortunate, but not as abundant as they previously were. I believe where we do have transects in an area that the population is really healthy, it was previously burned because I can see little sagebrush like dumps, like the tips sticking up, and they do take like 60 to 80 years to regrow and reestablish themselves. But sagebrush is the dominant cover there, probably because it's so dry. But yeah, that's a good question. I know that there are some students that are looking at fire intensity and looking at models to better illustrate that and find areas like that. I'm not able to necessarily include that in my data. But there is someone in my lab who's looking at phytoliths, so plant fossils essentially. And so there are charcoal that they're looking at, and that'll be really cool to see how that overlaps because their project is very much so Gunnison Sage-Grouse based as well. They're looking at how vegetation has changed over time, as well as seeing at the old fire regime. And so that information will be really useful when it comes to my thesis as well.
So in my project, I utilize the National Agricultural Imagery Program, which provides colored infrared data, which you can calculate the normalized difference vegetation index, which is an indicator of health, vegetation health. I don't think that it would necessarily be as applicable well, it probably would be. I don't know what the spectral signatures of sagebrush is, but it's a data set that should be releasing for 2024 within the next couple months if you want to use it. It's obviously remote sensing, but still a lot of information to be gained from it, and probably a good basis, especially if you want to do some image analysis as well.
What's that called?
The National Agricultural Imagery Program.
Okay.
Yeah, NAIP.
Okay.
It's really useful for vegetation analysis, and I mean, obviously it's collected by the USDA, and it can really, I think it would facilitate a lot of analysis for you, especially so you can do more regional analysis rather than just site analysis, which it sounds like mostly what you're doing is site analysis. So I think it would be very useful for you.
Yeah, that's good to know. Yeah, my hope is to be able to go from site level to, regional. Yeah, throughout the whole basin. That's like the ideal way. We don't really have enough sites at this point to be really confident about that, or at least enough to say like this model makes sense.
Yeah.
And I've done, aside from MVR, I've done other vegetation indices like NDVI and SAVI. I just haven't really looked at them and see if they are statistically sound with my data.
Well, I mean, I would say the biggest thing is the NAIP is collected in 2024. It has a 3-year reproduction cycle, and it's the highest resolution colored infrared data that you can access publicly. So,
Okay.
Yeah, it's sweet. I love it. So
Yeah.
It's informed a lot of my decision-making processes, so hopefully it can help you.
No, yeah, definitely. I'm always looking for more resources to get data from. Cool, thank you.
No problem.
Any other questions?
Cool. Thanks for having me.
Thank you so much. Next part will be our gutting panel, and Brian Frazier's going to run that.
Yes, probably got a few minutes if you guys want to take a bathroom break. Yeah, we'll take 15 minutes. We'll get started at 2. So, 30 minutes, I'll take a break.
I have a question. Do you know Caleb Road?